started. This morning we're going to be working on our math lesson for the day, and your learning target for the day is to you can create equivalent fractions and explain why they're equivalent. So I know you've been working with equivalency, so you're going to use some of those things you know about equivalent fractions to help you create some and then tell me why they're equivalent, okay? Turn and tell your neighbor what you're going to be doing today. Oh, so who can tell me, what are you doing today? What? You're working with equivalent fractions. What are you going to do with them? Yeah. You're going to make some. You're going to create some. And then what's the big thing you have to do besides make them? You have to what?
You've got to explain how they are equivalent.
Yes, so we got to explain how they're equivalent, right? So you have some models in front of you you're going to be using, but you're going to know you're successful with doing this if you can, let me rephrase that. When you have mastered it, when you can create those equivalent fractions and explain your model. So I'm going to be asking you lots of questions like, tell me about your model. How do you know they're equivalent? So you're going to have to be able to do that second part of our learning intention for the day, which is to explain. So, what's your favorite sandwich? Does anybody have a favorite sandwich that they like to eat? What's your favorite sandwich?
Bologna sandwich.
Bologna. Who likes bologna? Yeah, I don't like bologna. What's your favorite sandwich?
Peanut butter sandwich.
Peanut butter. Oh, yeah. What's your favorite?
Turkey.
Turkey. So we're going to be talking about a sandwich today, okay? Favorite sandwich for me? I don't really like sandwiches unless they're hot. Probably a grilled cheese. Anybody with me on a grilled cheese? Yes, grilled cheese. So favorite sandwich. So we're going to be talking about sandwiches today. And our two friends, Kaysen and Trey, okay? And Kaysen and Trey, Kaysen ate 2/8 of his sandwich, okay? And Trey ate 1/4 of the same size sandwich. They have the same size sandwich. May not be the same type, but the size is the same.
Right.
And Kaysen says he ate more than Trey. Okay, so is he correct? Why or why not? That's what I need you to help me prove. Because in math, as mathematicians that you are, we can't just say, yeah, he's right or yeah, he's wrong. We have to prove it. It's almost like being in a court of law, isn't it? So I want you to think about for a second. I hope you're thinking in your mind if he's right. Kaysen says he ate more than Trey. And what you and your partner are going to do, are you're going to use these pieces of paper to be, these are really weird looking sandwiches, right? But they're going to represent our sandwiches. So you can decide which one is Trey and which one is Kaysen and help me and you prove if Kaysen is correct. So at the end of our lesson, we'll come back and figure out, was Kaysen right? Did he eat more than Trey? And I wonder why he thinks he ate more than Trey. Thinking about that. So here's what I want you to do. You and your partner work together to prove, tell your partner what you think. What do you think? Do you think he ate more than Trey? And then how are you going to prove that he ate more than Trey? Or if he didn't, how are you going to prove he didn't? Are you ready? All right. I'm going to set my timer for our time to explore, and I'll be coming around and asking you some questions. So go for it. Start talking with your partner. You think so? So can you prove that Kaysen ate more? Sure. I want you to work on that, proving that. What are you going to, who's working on this? What are you folding here? Okay, so whose sandwich are you creating? Trey's. So you're going to create Kaysen, and why don't y'all see? So y'all are telling me that Kaysen did eat more. So I want to see if you can prove that. I'll be back to check on you in a minute, okay? All right, so guys, what do you think? Over here. You can fold your paper too. You don't have to draw on it. Folding might be easier for you if you want to fold it. But you can draw. That's okay. Tell me what you guys are thinking.
Well, I'm thinking that you can make these little triangles. If you had 4/8, you can make like 4 right here. And then you would have an equivalent fraction.
Equivalent to what? How would you know it was equivalent?
Because this is bigger than the other and it has the same amount. So if you pull out the other one and put it on here, it would be the same would be shaved.
Really? So I'm wondering though, how can Kaysen has 2/8, right? And Trey has 1/4. How is it possible for them? So what are you telling me? Is Kaysen right or not?
No, he's not right.
So what do you think he ate?
I think he ate the same amount as his friend.
So you think he may eat the same amount, but how's that possible? How can someone who ate 2 pieces eat the same amount as someone who ate 1 piece? So that's what I want you guys to think about. How could you prove that using these pieces of paper? If you need more paper, I can give it to you. So how could you prove that someone who ate 2 pieces of a sandwich, because you said it was 2/8, it'd be the same as one who ate 1 piece of a sandwich, okay? So y'all work on how can you prove that. Think about, talk to your partner. All right, tell me about what you're doing here.
I think you can do this.
Tell me about your model.
We say they both ate the same because 1/4 is equivalent to 2/8.
Oh, you think it's equivalent to 2/8? How is that possible? One of them has 1 out of 4, and the other one had 2. out of 8. How can something that has 1 be the same as something that has 2?
Just round it up by the number line. You can see that 2 H's lined up with 1/4.
Oh, you think so? How could you prove? Oh, you're going to draw that there? I love that. Let's draw that model.
If you had two fours,
Uh-huh.
2 fours.
2 fourths is what?
If you have 2 fours, that would be 8. If you have 2 ones, that would be 2.
Oh, so can you prove that with your model? What do you need to do? What are you creating here? Whose sandwich is this?
It's
This is Kason. How do we know this is Kason's sandwich?
oh wait, no, it's Trace.
This is Trace. How do you know this is Trace? Sandwich.
Because he only had 1/4.
1/4. So why? How many pieces did you make here?
4.
Why do you think, Kyler, he made 4 pieces? Why does he have 4 pieces?
To represent that Trey ate 1/4 by 4 colors and we had 4.
Because the denominator tells us what?
He ate 1/4.
What does the denominator, the number 4 in the denominator up there tell you? He ate 1/4.
1/4 would be shaded.
Okay, but what does the 4 tell you? Kyler, do you know what the 4 tells us in the denominator?
How many parts there is?
How many parts there are in the whole, right? So that's why you made 4 parts. And why are you shading 1?
Because that's what he ate.
Okay, so talk with Kyler. He's drawing a different model, which is fine. But talk with each other about how can you prove, though, because you're telling me that it's the same, that Kason's wrong. How can you prove it? So I want y'all to work on how you can prove that he's wrong. All right, tell me about your model here. What you making? These are 8s. Why are you choosing to make 8s? Okay. He ate 2, so you're making Kason's sandwich. And tell me about this. What does this represent? Trays. So tell me about what you decided to do here. If this is trays, how are they different? Okay, so you're saying Kason has more pieces and Trey has less pieces. What do you notice about the size of the pieces?
If you ate 1/4 of it, that means it's smaller and the 4s are bigger.
Okay, so the 8s are smaller pieces. So, but the 4ths are bigger pieces in size, right? So what do y'all think about Kason? Is he right? Did he eat more?
No.
No.
I just thought that he has more pieces.
Okay. You thought he ate more pieces. But did he?
No.
So why didn't he? Because he ate 2.
He had smaller.
Oh, say that again. He did what?
He had smaller pieces.
His pieces are smaller, so you're saying that they ate the same because his pieces were bigger, his pieces were smaller. I'm following you. How can you prove that, though? What are you trying to do here? Talk with your partners, but how can you prove that? All right, talk to me about your models. Tell me, oh, what is going on here? What's happening? What's she doing? You don't know? Let's talk with their partner. What is she doing here? Trying to measure. So tell me what this blue piece of paper represents. So this is Trace. How did you know to make 4 pieces?
I can't remember.
Do you know why she chose to make 4 pieces? Why does she have 4 pieces?
If it's the numerator, if it's down.
So let's look up there. So this is whose sandwich? Trace. So, and I moved you, didn't you? No, tell me your name, sweetie. Michaela, why do you think, looking at Trey's sandwich, how much did Trey eat? 1/4. So why do you think that Tinsley is making 4 pieces when you're looking at that fraction? Why do you think? There's 4 pieces. He cut his sandwich into 4 pieces. What part of that fraction tells you how many pieces are in his sandwich?
The bottom.
The denominator, right? So the denominator tells you how many pieces are in all. Why did she shade 1? Why did you shade 1?
Because the numerator is where that's how many shapes.
Gotcha. So tell me what you're doing here. So you have this is how many he ate out of 4 pieces, right? Why was Tinsley doing this? Why is she putting them on that like that? What's she trying to do? Trying to show that they're the same length. Is it working? No. So what are you thinking? Do you think Kason ate the same amount, or do you think he ate more? He ate more based on this? What do you think? So how could we, if you're trying to make this fit into here, why are you trying to make this fit on that? What do you think? Well, how do you prove something's equivalent? How do you prove fractions are equivalent? What'd you say? So if you were trying to prove they're equivalent, she's trying to put them on top of each other. If they were equivalent, what would happen?
They would be the same way.
They would be the same size, right? They would cover the same size. But this isn't working too well. I wonder, let me get you another piece of orange paper and think about how you folded this one, how you folded that one. If your 2 8s are here, or looking at this and where you shaded them, is there another place you could have shaded this one so it would fit? Let's turn it over on this side and see if there was, since you're trying to make it fit, why don't y'all talk with each other about what do you think, see if you can make it fit. All right, what's going on over here? Tell me about your models. Oh, tell me about this.
So, Kason is wrong because...
He's wrong. Tell me why.
Because 2 of these make up 1 of these.
Oh, but okay, then I'm confused. So 2 of these make up 1 of these. So you're telling me he's wrong. So what did they eat? Who ate more? Who ate more? Kason or Trey? What do you think? Kason? But you said he's wrong because there were 2 of these and they were the same.
I think they eat the same.
Oh, you think they ate the same. So talk with your partner, Madison, here about how you can prove that they're the same. Look at her model. See if you can help her model with this blue paper look like your model here. What could you do with hers? All right, tell me about yours. Oh, got the time. Tell me about your model. So you both have modeled. Tell me about it.
I think they're the same because 4 plus 4 equals 8, and if it's 1/4, then it would equal to 1/4 to equal 8.
Okay, so if you're saying, whose sandwich are you modeling here? Do you think? Whose is this?
This is Trey and his Kason.
He's Kason. So tell me about how you know this is Trey's sandwich and not Kason's.
1/4. Because it only has 4 would be.
Okay, and how do you know there was only 4 pieces in his sandwich?
Because it tells
It does. Math is bossy, isn't it? It told you he ate 1/4 of the sandwich, so there had to be 4 pieces in the whole, right? So this is Kason's. And so tell me about, wait, no, this is Trey's. Miss Lovis gets confused. I've been confused the whole day. Tell me about this. Tell me about how you decided to do this. So how many pieces is this whole divided into? 8. And why did you shade 2? Because there's 2 at the top. So the numerator tells you how many to shade. Okay, so it tells you the quantity of pieces. So did they eat the same amount? You're saying they ate the same amount. How can you prove that though with this model and that model?
because if you add
So what are you trying to do here to prove that they ate the same amount?
like to see if these 2 would if I put it in here,
Right.
if it would still show.
Right. So that's how you prove they're equivalent, if they have covered the same space. But are we struggling? Are these 2 fitting in here? No. Right. So let's think about this. How could we prove that? Would they fit in there? What could we do? I want you guys to talk about what can you do to this to prove that they fit in there. Is there something else you could do maybe on the back or the side? What could you do with these pieces? I want you to talk about that. I'll be back in a second. You were trying to prove, because y'all said that Kason ate more last time I was over here, if I remember correctly, right? So have you still agree with that? Why do you think Kason ate more? He had 8 pieces. Okay. So tell me about what you know. So you're saying because he had 8 pieces and he ate more. He had 2 and he ate 1. Tell me what you know about the size of their pieces. No, one was big and one was small. Which one was big? Trey's pieces were bigger than Kason's? So if Trey's pieces were bigger than Kason's,
Because if Trey's was bigger, he couldn't. Wait, no, Casey's would be bigger.
You think so?
Yeah, because he would have. Because he can't. He would probably just have to draw 4s if it was small. And if it was big for Casey's, he could probably cut it into 8s.
Oh, so we could have taken trays and cut it into 8s, maybe. You think? So what would we do to cut trays into 8s? If these are, tell me about your model here. This is 1/4. Where are the other 3/4 that you didn't shade? Here. And is this one shaded? So how many are shaded? 2. So how many did you want to shade? Did you accidentally shade too many? So if you're thinking about this as trays, so if we unshade that on that side, how could you prove, or you said you could cut it into 8s. What would you do to cut these 4s into 8s?
You could just leave them how they are, and then you could just cut them down into, like you could have 4 cuts on one side, and then 4 cuts on the other side.
Okay. So you're thinking if we could cut them, what could we do to this model that's in front of you to show 8s?
You could kind of put the sides together and then just slice like this side with 4, and then you could have the other side with 4.
Okay, yeah, 4 and 4 on each side. So if you're thinking about that on this one, if we fold this in half, right? So you have your halves there. What would you need to do to show 4ths? Y'all talk about that. How would you show 4ths, and then how could you show 8s? Okay, we're about to talk as a group. All right, tell me about yours over here. What'd y'all come up with?
I made a sentence.
You made a sentence. So prove it. What'd you prove?
I said I know that he did it wrong because we didn't prove because they put it a lot did eat the same because he put a lot had
Some of you were saying that Kason was right, that he did eat more. And some of you were saying that they were wrong, that they didn't eat more, that he didn't eat more. Some of you were saying that he ate what? If he didn't eat more, what did you say he ate? The same. So we're going to look at some solutions that you guys came up with, maybe, in just a second. All right, so let's take a look. I'm going to try to take a picture of these, maybe. That doesn't look very good, does it? Can y'all see that?
Yeah.
Oh, yay! All right. Now I got to display it. Here we go. Ta-da! I'm feeling so accomplished. All right, let's take a look at this model, okay? I'm going to set my timer so I don't share discuss too long. I want you to look at this model that some of your friends came up with. This blue model and this orange model. I want you to talk to your neighbor. I want you to talk about whose sandwich do you think this represents and why, and whose sandwich do you think this represents and why. Turn to your neighbor. Who do you think is being represented? Who wants to share? Whose do you think the blue one is? Who wants to share? Who do you think the blue one is?
Cases.
Why?
Because it has way more than the orange one.
What has way more what? Help him out. It has way more what? Pieces. How many pieces does it have?
8.
8. How do you know there needed to be 8?
Because 4 plus 4 is 8. 4 plus 4 is 8.
Yeah. But remember our problem? Kason ate what?
8.
2 8s, right? And so math is bossy. It's always telling us what to do. So it told us that we needed 8 pieces. The denominator told us we needed 8 pieces. Why did he shade 2?
Because he only ate 2.
That's how many he ate, right? And so if that's Kason's, then y'all agree that this is whose? Trey's. And how many pieces does it have?
4.
Why?
Because it told you in the story.
Hello, math is bossy. It tells you what to do, right? So it needed 4 pieces. But math is bossy, but what part of your fraction tells you how many pieces are in the whole? Denominator, right? The denominators tell us how many pieces are in the whole. So with this one, we've decided whose is whose. So I want you to look at this model, and I want you to predict what our friends, it was these 2 guys right here. What do you think their answer was? Because some of you thought it was the same, and some of you thought Kason ate more. Based on what they have here, what do you think they thought about Kason? Is Kason right, or is Kason wrong? Because remember, Kason said he ate more. Turn and talk to your neighbor. What do you think they said and why? Friends back here, let me get your names right. Jimmy and Stephen were thinking. Do you think they thought Casey was right or wrong?
Wrong.
Wrong. Why do you think you thought they?
Because the 2 8 looks like it's equal to the 1 4.
Okay. How would you know it's equal?
Because if you put 2 parts and you shade them directly the same, you can put them on top of each other and measure the length and stuff to make sure they're the same size.
Gotcha. So if we put this one on top of this one, would they be exactly the same? Yeah? So if I put this one right on top of it, would it be the same? Yeah. So is that what you thought, guys? Was it equivalent? So Kason was wrong. He did not eat more. Is that what you're saying? Okay, then I'm confused. Why did Kason think he ate more? So remember, we're trying today to talk about why fractions are equivalent and to prove it, right? And so I'm wondering why Kason would think he ate more, even though this is the same. Turn and talk to your neighbor. Why do you think?
Because he had
Why do you think Kason thought he ate more than if he obviously ate the same amount? What do you think?
Kason thought he ate more because he has more pieces.
Do y'all agree with that?
Yes.
That makes sense, right? If I have 8 pieces, is there another reason why he might have thought he ate more? Yeah.
Because if he had 2 bites, he thought he had more than, he thought 2 bites was more than 1.
Yeah, that makes sense. I had 2 bites. You had 1 bite. I ate more. Right?
Yes.
But he's wrong. Because why?
Because the parts are not the same size, but if you put them together, they can be the same size to make it.
Let's listen to what Tinsley just said. She said the parts aren't the same size. They cover the same area. Which parts are smaller? Trey's, right?
Yeah.
His parts are smaller. He has more of them, doesn't he? So if I'm going to eat the same amount, if Trey and Kason ate the same amount, he's going to have to take more bites because his pieces are smaller. Interesting. So they ate the same, and we think Kason thought that because he had more pieces. And so if the pieces are smaller, how could I have made Trey's look like Kason's? What could I have done to Trey's model to make it look like Kason's? Turn and talk to your neighbors. What would I do to make Trey's look like Kason's? Remember, we're generating equivalent fractions today, so how would you do that? To make it look like Kason's. What can we do to it? What do you think, Caitlin? Slice it in the middle. Can you slice that in the middle for me, like she just said? The orange one? Can y'all see that? All right, you slice it right down the middle.
Like this?
Yes. Ta-da! Now let's look. Did we generate an equivalent fraction?
Yeah.
Yeah, now they're exactly the same, right? They both have 2 8 shaded. So Jimmy was able to create one by slicing it right down the middle. So we're able to partition it, and the pieces became what? They became equivalent, but they were equivalent before. Before he sliced it, they were equivalent. Let's look at it again. Before he sliced it, they were equivalent. Let me take a picture so I'm not shaking. What happened to the pieces now? Here's the pieces before. Here's the pieces now. What happened? Yeah.
They got smaller.
They got smaller. We didn't change the number of pieces. We didn't put more pieces in there. The whole stayed the same. All we did was cut them up. So to generate an equivalent fraction, what can you do?
Slice it down.
Slice it up. Yeah, we could. It makes some equivalent fractions. So I have one more for y'all to look at because y'all told me you've proven how to create an equivalent fraction. You've proven that Kason was wrong. Bless his soul. He was wrong, but we helped him out, right? And that was obvious. It was something we understand why he would think that, right? Because the pieces, a bunch of them, he ate more of them. Obviously, he ate more, but obviously he didn't, right? But let's take a look at this one really quick. Because I want you to look at this model here. Maybe. Let's go get the hang of this in a minute. So look at this. Does this compare to the model we saw before? Remember?
Oh.
So did they show where's Kason's, where's Trey's? Do you see it?
Yes.
So to prove it's equivalent, talk to your neighbor. What would they need to do to prove these are equivalent? Talk to your neighbor. How would they need to prove they're equivalent? To prove these are equivalent, what would you do? Try to do to these?
flip it.
Flip it, he says. Y'all know what he means by flip it?
Yeah.
What does he mean by flip it?
So like the 2 8s are like this, then you move it like that.
Okay, I'm trying to. But is it working out here? Wait a minute. I'm confused. It's not working out, y'all. What's happening here? Why it's not fitting? I thought you said if they're equivalent, they'll fit on top of each other. Why aren't they fitting? Look at that. Why isn't that fitting? And what could we do to make it fit? Could we do something to make it fit?
To make it the other way, to make it go up and down.
Oh, you could shade a different part. You could. What do you think?
I think you could like slant the orange one to where it fits the blue one.
Slant it to where it fits the blue one?
Yeah.
Yeah.
So like make it go up and down.
So to make this fit on that, I'm hanging off the side there. So what could I do to this orange one? Yeah, what'd you say? You said it. Somebody said
Cut it.
cut it, right? We want to cut it. And Miss Love is not prepared with scissors. Ah. So if I cut this out, so you think if I cut this, I could make it fit on there? So here's my 2 8s, right? Let's see if it works. I'm going to see if they'll fit. Well, if I could cut straight. Here you go, let's look. Do you think it worked?
Yes.
Let's look. Oh my goodness, it did work. So what was up, y'all? Why did a minute ago it didn't look like they were equivalent?
Because
But now,
than the other.
now they're equivalent. Turn and talk to your neighbor. Why did it not look like they were equivalent and now they are?
First it wasn't cut. First it wasn't cut, but now
Okay, bye.
And then you could see if it was equivalent or if it was.
Right, so if I could cut it and put it on top of it, it was equivalent. But why didn't it fit the first time? Because they were the same size, y'all just said. Why didn't it fit the first time? Different angles, different. The shapes were a little bit different. Okay, so come back together. You guys just talked about why they didn't fit the first time. What do you think?
I think it was hanging off the edge, I think, and then
So it did look like this, right?
yes, it was hanging off the edge, but it didn't work because it's bigger. Because the other piece
Was it bigger? So is it, if it's equivalent, are the pieces bigger?
If you twisted the parts, it's longer length this way, but it's shorter length this way.
I think you got it. The key was they do cover the same space, like we proved here by cutting it, but they were different shapes. So just because they look different, and some of you like, I'm going to show this one really quickly. Look how he cut his into 8s. Can y'all see that?
Yeah.
Look how he cut his into 8s. You see all that? And he originally, was that on the other side? Let me look. No, he erased it. But he originally had these two shaded to show trays. Why do you think he switched over here? Turn and talk to your neighbor. He originally had these 2 8s shaded. Why do you think he switched to these 2 8s shaded? Turn and talk to your neighbor. Why did you do that?
Because they were different lengths and sizes. On the other piece of paper and match it up instead of putting it like this because it would be the same shape.
What do you think?
Because they were different lengths and sizes.
So when he moved them over, he was able to do what?
Get them equal.
Yeah, to match up a little easier. They still matched up. It was just harder to do when they were there. All right, so let's come back together. Why did he move his? He had 2 8s here originally. He moved them over here. Why did he do that?
Because they were different lengths and size.
Yeah, so their size was the same because their size still fit in the same spot, right? But their shape was hard to match up. Like we were having a hard time matching these up. Our friend, Leland, is it Leland? Mm-hmm. Leland was having a hard time matching these up to his 4. So when the shapes are different, even though they're same equal, the shapes are different, it's harder to match up. So you guys have worked so hard today with your learning target. You have, I believe, mastered that. Remember what we were learning today was to create equivalent fractions and then you had to explain why they were equivalent. Feel like you did that today? Mm-hmm. I do. Somebody refresh my memory. What was it again we did to trays to make his equivalent?
We had to prove it.
We had to prove it, but what did we do to trays? What did our friend
Slice
Jimmy do
it
to
down
trays?
the middle.
Sliced it, right? So if we wanted to create some fractions, we can cut them up. As long as the area stays the same, we're good to go. You guys did an awesome job today. Thank you so much for letting me come and teach in your classroom. I really enjoyed it. So I hope you have a great rest of your day, okay?